Now, in this slide, I want that you think about this amazing property of water, that is that the solid version, the ice, is less dense than the liquid water. And this is something very atypical. And again, is due to the hydrogen bonds as you watch in the video. And now here I want to ask you this question. I know that you already watched the video, so you should know why water or why ice is able to float in water. And you know also the answer, hydrogen bonds. Yeah. So we know that the water can exist as a gas, as a liquid, or as a solid. And generally, in many compounds, the solid will be the most dense of all these states. However, in water, something very different happen because of hydrogen bonds. So water will be less dense than the solid liquid because of the hydrogen bonds. So if you compare the hydrogen bonds in water to the hydrogen bonds in a liquid, you will see a strike difference. While the ones in water are very disorganized, the one in ice will be much more stable, and you see they have this beautiful packing and geometry. So the ice hydrogen bonds are very stable and are less dense packed, while the liquid water hydrogen bonds are constantly breaking and reforming. So as the ice crystals that you can see here, these beautiful hexagons here, these one are less densely packed than in liquid water. As a result, the ice is able to float in water. And I'm not going to talk a lot about the water cycle. I'm sure that you studied that in high school, and if not, you can give it a read in the textbook. But remember, the circulation of water is very important, and evaporation is important, and then it goes back into the planet. So I know that you have seen hundreds of times this cycle, so I'm not going to focus on that. But if you have any doubt, go and read it in your textbook. In this section, I'm going to talk about water as a solvent of life, and I want to give you three main definitions. What is a solute, what is a solvent, and what is a solution. And a solute is the substance that is dissolved. So if you have coffee and you put it, an instantaneous coffee, and you put it in water, the coffee will be your solute. The solvent, it will be the dissolvent agent. In the case of the instantaneous coffee, will be water. And finally, a solution is the liquid consisting of a uniform mixture of two or more substances. So remember, very important, it has to be very uniform. You cannot have clumps. Yeah, that will not be a solution. So for example, in living organisms, when you have lipids, like in the membrane, you have oil, you will have two phases. So this will not be a solution. And now to finish, I just want to remind you, this could be in the exam. An aqueous solution is one in which water is the solvent. I'm going to talk about why water can be a solvent of some molecules, and the main reason is because of its polarity. And I just remind you that when you have a molecule of water, you will have hydrogen and you will have oxygen, but the oxygen is much more negative, and these are much more positive. They are less electronegative, so the hydrogens will locate closer to the oxygen. And this is very important because it will create a polarity in the water molecule. And this will be very important for properties like the hydrogen bonds that we have been talking, and also is important for the solvent properties of water. So, for example, when you have a polar charge solute, for example, when you have a tablespoon of salt and you put it in water, what is going to happen is that the sodium chloride is going to split into two ions, and if you see the chloride is going to be close to the hydrogens, to the white circles in this schematic, because the hydrogens will be positive, yeah, they will be positive, so they will be attracted to the negative chloride, while on the other hand, the sodium will be attracted to the red circles that in this case represent the oxygen, because the oxygen, remember, it will be negative. So both will be attracted and they will dissolve in water. So for that reason, they will form an aqueous solution. And to finish, I just remind you that, as I said, table salt is an example of a solute that will go into a solution in the presence of water. And why? Because of the polarity of the water molecule. To finish this section, I want to talk about the importance of the search of water as a tool to look for extraterrestrial life, and also as a way, maybe in the future, for humans to migrate to other planets. So maybe you have heard this news. They sent a robotic arm to Mars and they found evidence of water. And as I said before, if we are looking for life, so astrobiologists are looking for life that looks similar to our life, the life that we have in our planet, the first thing that we have to look is for water. NASA found evidence that water was once abundant on Mars. There is this question whether in the past there were life in Mars, the life in the Earth could have migrated from Mars. But anyway, there are many more questions, and we are still looking for more planets that have water.